Okay, we're going to begin here with the lesson 4.5. And if you look in the PowerPoints, you'll see this outlined, but I'm just going to give you a quick summary here. We're either looking for vertical asymptotes, in which case after we simplify as much as we can and factor out, then we solve the denominator equal to 0, and whatever value we get for x equals a number, that'll be a vertical line, and that'll be an asymptote where the graph approaches but doesn't quite hit. For horizontal asymptotes, you're looking for the ratio of a to b, assuming that the powers of x are equal. So if the power of the variable is equal in the numerator and denominator, then you're going to take the ratio of the coefficients, in this case a over b, and it would be y equals a number, like y equals 2. And that would be a horizontal line like this that the graph would approach. And the other another example here is called an oblique asymptote. So that means diagonal. So instead of vertical or horizontal, you could also have an oblique asymptote, which is diagonal. And that typically happens after you simplify and factor out, where you have the numerator has an exponent that's 1 higher than the denominator. And if you divide the denominator into the numerator, you can get the exact equation of the oblique asymptote, but typically it's of the order of it's a line. It's y equals x, or x plus 2, or x minus something. So it's going to be something of the order y equals mx plus b. And that's an oblique asymptote, which is going to be a line. So that means you'll have a graph that approaches a diagonal line, also called oblique. And in the last case here, if you have a numerator which has a power that's 2 higher than the denominator, then you're not going to have any asymptote at all. So we're going to say that part's going to be none. So for the first example here, we have f of x is equal to 10 plus x over 3. Now in that case, we're looking for an equation for the horizontal or oblique asymptote. Well, first of all, we're asking for the first one is the equation for the vertical asymptote. Well, the equation for the vertical asymptote, nothing can be factored out, so we're simply going to say that x is equal to negative 3. And that's the equation for the vertical asymptote, because that solves the denominator equal to 0 after everything could be simplified. Okay. The next one is the equation for the horizontal asymptote or oblique. Well, in this case, we have, if there's nothing there, it's like saying it's x to the 0. So the denominator has an exponent that's greater than the numerator. So therefore, as x gets really, really big, let's say towards infinity, it's going to be, as x gets really, really large, kind of like that, this is going to approach 0. So the equation for the horizontal asymptote is going to be y equals 0. So the exponents aren't necessarily the same, but we can tell the end behavior as x gets really, really large, this whole fraction goes to 0, so therefore it's y equals 0. Alright, there is no oblique asymptote in this case. So that'd be y equals 0. The next one there asks us for 4 ordered pairs. So we just take this equation and pick any numbers we want. I recommend picking numbers that make this a multiple of 10. So like a 2 makes it a 5, makes it a 10, makes it a 20. Something that 10 is going to divide equally into to make it easy. So I picked 2, for instance, because I know if I put 2 in the denominator, it's going to make 5. So therefore 10 over 5, that's going to also be 2. Likewise, if I put 7, that's going to make the denominator equal to 1. So that's going to be 7 comma 1. If I put a negative 1 in there, that's going to make the denominator 2, and I know that 10 divided by 2 is going to be 5. It doesn't have to be these 4 answers, these are just 4 suggested ones. And if I put a 12 in there, it's going to make the denominator 15. So 10 over 15 is going to be 2/3. That's just one way you could do it. You don't have to do it exactly that way. Now here, we're looking for an equation for a vertical asymptote, and here's the equation. Well, we're looking for a vertical asymptote. We'll solve the denominator equal to 0, and we get x equal to 4. We can't simplify anything out. Anything more that's going to affect the denominator. So we're going to get x equals 4. That's our vertical asymptote. Now here we're looking for an equation for a horizontal or oblique asymptote. Well, we look here, and we have the same power, x to the first power, x to the first power. So we're going to get we're going to get y is equal to negative 3 from our horizontal asymptote. Y equals negative 3. Because we have same power, and the ratio is going to be negative 3 over 1. Okay, and then we're looking for any pairs of exponents that will be on this equation, on this function. So I picked like 0 and negative 1/2. If you put in 0 here, you'll see that it becomes negative 1/2. I put negative 2 comma negative 4/3. You don't have to use mine, but I use small numbers that are pretty easy to compute. I did 1 comma 1/3, and then maybe negative 1 comma negative 1. Slow it down, look at the video later, and you'll see that those work. Now down here, we're looking for looking at equations for a vertical asymptote. Well, we have to kind of try to see if we can simplify this first. If we try to simplify this first, we divide out by negative 9x, and we're going to get y equals negative x something, right? So therefore, I'm not going to have anything in the denominator but a 1. So the equation for a vertical asymptote, there's going to be none, because I'm not going to have a variable left in the denominator after I try to simplify that. So for a horizontal, it's not going to be a horizontal asymptote because I don't have the same power, but maybe it can be an oblique asymptote because it's greater than 1. So you see how the numerator has an exponent that's 1 higher than the denominator? So we're going to divide negative 9x plus 2 into negative 9x squared plus 47x minus 10. And see what because they're asking for the equation of the oblique asymptote. So if we divide that into that, we're going to get negative x. Positive x. And then we're going to get negative 9x squared plus 2x. And then we subtract. And if we subtract, we're going to get 45x minus 10. And then we divide negative 9x into negative 45x. And that's going to give us minus 5. So multiply it down, we're going to get 45x minus 10. And that gives no remainder. So that means y equals x minus 5 is our exact equation for our oblique asymptote. Okay, in the next one, we're asked to find the equation of the oblique asymptote. So we want to divide this out. So we have 3x plus 6 into negative 9x squared plus 9x plus 10. Now we know that our numerator is greater than the denominator. The degree of the numerator is greater than is 1 more than the degree of the denominator. So that's why we're looking for an oblique asymptote. So we divide that in, and we get negative 3x. Multiply it down, we get negative 9x squared minus 18x. We subtract, and we're going to get 27x plus 10. Bring that down, and we're going to get 9x. Plus 9, sorry. So if we multiply it down, we're going to get 27x plus 54. And even though we don't get an exact answer here without a remainder, it doesn't matter. We get negative 44. We take what we have up here, and that's going to be our equation for our oblique asymptote. Y equals negative 3x plus 9. It doesn't have to come out exactly. Now right here we're asked for an equation for a vertical asymptote. Well, after we divide out common factors of negative 6x, we're going to get a negative x in my numerator. So my denominator, I'm going to have a 1. So this cannot go to 0. So therefore, I'm going to have no vertical asymptote. Okay? Remember to look to factor first any common terms before we try to solve the denominator equal to 0. And at the bottom here, we're asked to find an equation for a vertical asymptote. So we try to find the equation for the vertical asymptote. Well, we can't divide this out directly by a common factor, but we can try to factor that equal to 0. So if we factor that equal to 0 there, what can we get? We can get so we're looking for a vertical asymptote. We're going to try to divide that out first. It's just solving the denominator equal to 0 because we can't simplify that first. And we're going to get x plus 2, x minus 2. So any of those values, so you're going to get x is equal to 2 and x is equal to negative 2. Those are the equations of the vertical asymptotes right there. And for an equation for the horizontal or oblique asymptote, well, our numerator is greater, or degree of the numerator is 1 more than the degree of the denominator, so we could have an oblique asymptote. So we're going to divide out x squared minus 4 into, negative x cubed minus 2x squared minus 2x minus 3. I think that's all minuses there. So it's going to go in there negative x times. So bring that up there for you a little bit. and multiply it down, you're going to get negative x cubed plus 4 plus 4x. So when we subtract, we're going to get negative 2x squared, and you're going to get minus 6x. I think that was a positive 2x in the beginning of the problem, actually. So there was a positive 2x in the problem. So this is a positive 2x. And we divide x squared into positive 2x squared, we're going to get positive 2. Okay, so we multiply that 2 down, we're going to get 2x squared minus 8. So we subtract, notice I line up these columns properly. I put the 8 over here and the 6x over here. So negative 6x minus 8, and we can no longer divide because x squared does not go into negative 6x, so we stop there. And we have y equals negative x plus 2, and that'll be the equation of our oblique asymptote. All right, last couple here, the equation for the vertical asymptote. For this equation here, we're going to try to factor if possible. It's going to be x minus 7, x minus 9. So our equations for the vertical asymptotes are x equals 7 and x equals 9. And the equations for the horizontal or oblique asymptote, if you take a look here, you look at the ratio of these two powers, and you're going to get y is equal to negative 1. So the ratio is the same, so that's going to be a horizontal asymptote, so that's y equals 1 right there. Now you can plug in some points right here. It's arbitrary. I just chose these, 0 and 1, and then negative 1 would give you negative 1 over 40. Just be careful plugging it in. You get comfortable as you try more and more of these. It doesn't matter which ones you use as long as you're careful and the answers work out. Now we have this one, and we're asked for vertical asymptotes and to graph them. Well, we try to factor this. It's going to be x minus 6 times x plus 6. And that's going to be a vertical line here and a vertical line here at x equals 6 and x equals negative 6. Use the graph to figure that out. And then they ask for horizontal asymptotes. Or horizontal asymptotes, you look here and you're going to see that the denominator is going to get larger than the numerator. So it's going to go towards 1 over infinity, which means it's going to go towards y equals 0. So you're going to have y equals 0 as a horizontal asymptote right here. Next one here is we're asked for y equals 6 over x squared minus 4. We're looking for a vertical asymptote. Vertical asymptote is going to be when you set the denominator equal to 0. So we're going to get x squared is equal to 4. So we're going to get x equals 2, and we're going to get x equals negative 2. And x equals 2 and x equals negative 2. We're right there. Okay, and then we'll get right there in horizontal asymptotes. That's going to go to y equals 0 because the denominator is going to get really large. So it will be 6 over infinity, so it's going to be at y equals 0. And that's it. And last one, vertical asymptotes. In order for that to be 0, it's a difference of cubes. So we're going to x equals 4 would make that 0 to make it 64 minus 64. So that's going to be x is equal to 4 for our vertical asymptotes. Horizontal asymptotes right there, or oblique. Well, the denominator has a higher degree than the numerator right there. So that means that as x gets really, really large, you're going to get 1 over x, which is 1 over infinity, which is 0. So you're going to get y equals 0 as my horizontal asymptote, and that's it for that one. Thank you so much, and that sound was my daughter.